Good evening, students. Today I am going to provide you one video from the first chapter of class 10, and the name of the first chapter of physics is force. And in this class 10 you are going to study about force of gravity or force of attraction, and these laws are mostly given or discovered by Sir Isaac Newton, one of the greatest scientists, one of the greatest physicists of this century. And okay, let me start from this chapter. And look here, so before we start, first I'll give you some idea. And let us suppose there are two bodies, okay, two bodies, any object or bodies, and these bodies may be very small, very microscopic also, or these bodies they might be very large, heavenly, even heavenly bodies also, like sun, moon, stars, planets, etc. And suppose if we take any two bodies, and the distance between these two bodies from their centers is small d, and the distance may be 1 kilometer or thousands of kilometers or some few centimeters also. So if the distance is d, small d, and mass of these bodies are m1 and m2, suppose the mass of the first body is m1, mass of the body A is m1, and the mass of the body B is m2, and when these bodies are kept at a certain distance d, then there is always a force of gravity, force of attraction due to gravity between them. Anything, okay, any objects, any two objects, when we keep them at a certain distance, they will start attracting with each other like magnets. And this force of attraction is called force of gravity, okay, or simply force of attraction also we can say. And the force of attraction between them is always proportional to the product of their masses. For example, if the mass of this body A is let's say 2 kg, and the mass of body B is, let's say, 5 kg, 2 kg and 5 kg, so 2 into 5 is 10, isn't it? So that's why the force is not exactly 10, but it depends upon this product, okay. Suppose if the product is less, if the product of the masses of these two bodies is less, then the force of attraction is also less, and if the product of the mass between them is higher, then the force is also higher. So that's why the force is always directly proportional to the product of their masses, m1 into m2, when these two bodies are kept at a certain distance. And the next one is the force is indirectly proportional, okay, proportional to the reciprocal of d square, distance square. Means if the distance is higher, then the force will be less, and if the distance is less, then the force will be higher. Means they are indirectly proportional to each other. The force of attraction is indirectly proportional to the distance. Means if the distance is very high, then the force of attraction is very less. You can suppose two magnets, okay, like they are like two magnets. If the two magnets are kept very close to each other, what will happen? These two magnets will attract with a more force, isn't it, higher force. But if these two magnets are kept farther, then they will attract with less force, and if we keep very far, they will not attract also. So like that, here also it is inversely proportional to the distance. Distance increases, force decreases, and vice versa. Distance decreases, force increases, distance increases, force decreases, just opposite. And so when we combine these two equations, equation 1 and equation 2, then the force will be proportional to the m1 into m2 divided by d square by combining these two equations. And if we want to replace this proportionality sign by is equal to, then we must keep one constant value. So I replaced this equals to sign instead of this proportionality sign. Instead of this proportionality sign, I have written is equal to. So when we write is equal to, we must write some constant value. So here the constant value I have written is capital G, and after writing capital G, we can write is equal to. So capital G is the constant value, and this capital G, it is called universal gravitational constant, and its value is always 6.67 into 10 to the power minus 11 Newton meter square per kg square. This is the unit of capital G. Okay, so this is called as the formula of force of attraction, and this capital G's value is always constant. It does not change, and it is constant for anywhere in the universe. In any part of the universe, the value is always 6.67 into 10 to the power minus 11 Newton meter square per kg square. That's why this is called universal gravitational constant, this capital G.